All right, more on rational functions. So 9.4, we are multiplying and dividing rational functions. Okay, so if you just recall that a rational function is very similar to a fraction, okay? Except you just have a polynomial in your numerator and in your denominator, okay? So the first thing we have to look at is how we simplify them, right? So just like a fraction, okay, you are looking to cancel out common factors. Okay, so you have to be able to factor the numerator and the denominator in order to simplify. So if you have A, B, and C are non-zero real numbers. Or variable expressions, right? Then if you have AC over BC, so A times C over B times C, the C's can cancel because they're common factors. They're not being added or subtracted. They're common factors. So you can divide them out and simplify that to A over B. Okay? So it's the same for a fraction that it is for a rational expression. Okay? Canceling out common factors. So in order to simplify, first factor. So, for example, x squared plus 3x over x squared. Yes, they both have an x squared, but they're not written as a product. Okay, this x squared in the numerator is a term, not a factor. So I'm going to factor the numerator and the denominator. So I can rewrite the numerator as x times x plus 3. They both have an x in common, so I'm factoring that out. And then dividing by x times x. Okay, then you're looking for a common factor, not a common term. So the x's can cancel, and you're left with x plus 3 over x, right? Do not cancel out these x's. They are terms, not factors, or at least a term up here, not a factor, okay? So that's the first thing when it comes to simplifying is canceling out common factors. So if we have the next one, right, x squared minus 5x minus 6 divided by x squared minus 1. This is where all of your factoring practice will come in, okay? So factor the numerator. Are there factors of negative 6 that add up to negative 5, right? So I can write that as x times x plus 1 times x minus 6. Because 1 times negative 6 is negative 6. 1 plus negative 6 is 5, or negative 5. Okay? Then the denominator is the difference of two squares. So that's going to be x plus 1 times x minus 1. Then are there common factors to both numerator and denominator? And there are. So we're going to cancel out the x plus 1's, and we end up with x minus 6 over x minus 1. You cannot cancel out the x's. They are not factors. Okay? All right. When you are multiplying, right? How do you multiply fractions? You multiply across. So multiplying rational expressions, same thing. You're going to multiply the numerator, then multiply the denominators, and simplify. Okay, just like you did with a fraction. So we want to multiply 6x squared y cubed over 2x squared y squared, that's one rational expression, times 10x to the third, y to the fourth, divided by 18y squared. Okay, so I am going to just multiply across, right? When I multiply, I'm going to gather my like terms. So I'm going to have 6 times 10 times x squared times x cubed, because we can multiply in any order, times y cubed y to the fourth. Okay? Same thing in the denominator, just multiply across. So the numbers, we get 2 times 18. Then our x terms, so times x squared, and then our y terms. So times y squared times y squared. Okay, then simplify. So if we're looking at the numbers, right, we could do 6 times 80 and 2 times 18 and then simplify. But I'm going to simplify within here. So 6 is 2 times 3, so we're going to cancel out the 2. And then 3 goes here. Yeah, so 6 and 1. And then can cancel out a 2 and get 5 and 3. Okay? So then we get 5 over 3. And then we'll deal with our variables. Okay? So like bases, when you are multiplying, you add. So x to the 2 plus 3, that's x to the 5th, divided by 2, or x squared. So 5 minus 2, we would get x to the 3rd. And then the y's. So in the numerator, we're going to add. So same base, add the numerator. So that's y to the 7th, then subtract 2. So y to the 5th, subtract another 2, y to the 3rd. And we get 5x cubed, y cubed over 3. Okay? Dividing, all you have to do is keep the first and flip the second. Change to multiplication. And take the reciprocal of the second, right? So if we have A over B divided by C over D, you keep the first, change it to multiplication, and take the reciprocal of the second, and then simplify. So we have 3 over 4x minus 8 divided by x squared plus 3x over x squared plus x minus 6. Okay? So division tells us keep the first. So we get 3 over, I'm going to factor as I go. It's going to make it a little bit easier for us. 4x minus 8, I'm going to factor out a 4 to get x minus 2. So kept the first, changing the sign of the second. So I'm going to multiply the reciprocal. So the x squared plus x minus 6 comes up to the numerator. That can factor to x minus 2, x plus 3. And then the denominator, same thing, okay? This is x squared plus 3x, so it comes down here. So we're going to factor out an x, and we get x plus 3. Then multiplication, you just multiply across. So there are any common factors I can cancel. So x plus 3's cancel, x minus 2's cancel, and we end up with multiplying across 3 in the numerator and 4x in the denominator. Okay? So multiplying and dividing rational expressions are just like multiplying and dividing fractions. Okay? So let's look at a couple more examples, okay? So how about 3x minus 27x cubed over 3x squared minus 2x minus 1 times 3x squared minus 4x plus 1 divided by 3x. Okay, so multiplication means we just multiply across. So we're going to factor everything. So the first one, we are going to take out a 3x. So we get 3x times 1 minus 9x squared over 3x squared minus 2x minus 1 factors to 3x plus 1 times x minus 1 times, here we're going to get 3x minus 1 times x minus 1, just factoring that numerator in the second rational expression, over 3x. Okay, except this is not completely factored. This is the difference of two squares. So we're going to get 3x times 1 minus 3x times 1 minus, or plus 3x over 3x plus 1 times x minus 1. It's multiplication, so I'm going to put this all as my one numerator, 3x minus 1, x minus 1 times 3x. Then we're looking for common factors, okay? So right away, the 3x's cancel numerator and denominator. Then we have 3x plus 1. It's the same as 1 plus 3x. We can add in any order. So those are going to cancel. We also have an x minus 1. So those can cancel. Okay? So in the numerator, what's left is 1 minus 3x times 1 plus 3x. Right? But these are not quite the same terms. They differ by a negative. So if I factor out a negative from here, I get negative 1 plus 3x. Don't ask me where this came from. I copied it wrong. It should be 3x minus 1. And then 3x minus 1 here. These are now the same terms, so we can say that's negative 3x minus 1 squared. So they differed by just a negative. So factoring that out made them the same terms. Okay? All right, let's do one more division, or let's do one with all of them. Okay? Whatever rules apply to fractions apply to rational expressions. So we're going to simplify x over x minus 2 times 2x plus 3 divided by 4x squared minus 9 over x minus 2. Okay? So multiplication, this is really just over 1. So we have the first two factor as we go. So multiply here, x times 2x plus 3 over x minus 2. Then it's division, so we're going to multiply by the reciprocal, so x minus 2. 4x squared minus 9 is a difference of two squares, so it's 2x minus 3 times 2x plus 3. Now it's multiplication. So cancel common factors to numerator and denominator. We have a 2x plus 3. We have an x minus 2. So multiplying across, we get x in the numerator and 2x minus 3 in the denominator. Do not cancel out those x's. They are not factors of the denominator. It's part of a term, not part of a factor. Okay? So whatever you do to a fraction, you can do with a rational expression.